You can tell I haven't even reset from the last lab very much. I need to erase some stuff. We're no longer dealing with work and energy. Now we're dealing with momentum. And momentum means collisions. Isn't that fun? So I want to introduce you to these carts a little bit. I don't know if you can see on them, there's a little bit of Velcro on each end. And I've marked a little dot. Where this little dot is where there's a magnet inside, and they're polarized. So what we're going to do is collide these carts together. The carts are labeled. There's a helpful 1 and a 2. I don't know if you can see those. We'll bring it up close when we do it. But we'll push one cart into the other. And when the dots are not together, the Velcro sticks and the carts stick together. So that's fairly straightforward. The idea is we're going to measure the velocity before and after. And one cart's going to be at rest, so we know its velocity is 0. And we're going to measure what happens with the other cart. Now, the other version of this is that we're going to have a cart sitting here, and another cart comes into it, but the magnets interact. That means they don't touch, and they bounce off of each other. And you can see what happens. If the heavy cart's at rest, the light cart comes in and bounces away, but it gives some of the momentum to the second cart number 2, the one with the masses. So we're going to observe what happens. Now to do that, we've got a second sensor at the other end of the room. But for the first measurement, all we need is to set up so the cart sits in the middle of the track, and so that we have a nice collision where everything sticks together. This is the inelastic collision portion. Now, M1 is going to represent the cart that has the 1 on it in yellow tape, and it is 0.5109 kilograms. Again, these are pre-weighed. There might be some error in the 4th digit, but 0.5109. Cart number 2, which is on the track, that's the one we had in the work energy lab, where your weight there was 1.5778 when it was all added together. Now, when we get to the end of this, I'll take those weights off so that these things are approximately equal weight, and I'll show you what happens when an elastic collision occurs at equal weight. But in the meantime, this is not too terrible of a thing. We're just going to have it sit here. We're going to run the sensor. I'll have it sit down there a little bit more. So I'll show you what it should look like. If I can get the lab quest to go. All right. So we're going to run it and then push into it. And you see it move. Now, when we look at the graph, this is actually good enough for data, I think. When we look at the graph in autofocus, there we go. So when we look at the graph, you can kind of see what's going on is that there's a velocity. We're not going to use the velocity. We're going to fit the curve here. So we're going to select a little bit of data. Select a little bit, and we're going to analyze, and we're going to curve fit. And we're just going to do a linear fit, and our slope is going to be our velocity. And we're going to go ahead and take this. So this is our initial point. We're looking at the initial velocity that this thing sees. And V1 initial is the velocity for cart 1, which is moving, is 0.54223. You can see that the slope, M, is going to be our velocity where we did this fit. I hope you can see that. So what we'll do is cancel this, and we'll go back. You highlight a little bit of area, analyze, curve fit. position. Analyze curve fit position. And then you select a linear fit, and you get 0.54223. So we're going to say, okay, that's fine. Now we're going to select a point after the collision. After the collision, the velocity changes. So we select some area after, and we curve fit that. Analyze curve fit position. And we do a linear fit. And this is, again, we're going to mark this for cart 1, but this is cart 1's final, and it is 0.11519 meters per second. All right. So its initial velocity for cart 1, the one we pushed in, is 0.54223 meters a second. And the final velocity is 0.11519 meters a second. Okay. Now, the rest of this we can figure out. We didn't have a sensor for cart 2, but we know cart 2 started at rest, so it's 0. And we know that it is physically stuck cart 1 now. So it has the same velocity, 0.11519. So your data table, now you want to be careful of your data table, is it puts V1 on one side and V2 on the other. And it's going to do the same thing down here. When you calculate the momentum and kinetic energy, mass 1 is going to be on one side. So you can put in 0.5109 kilograms and 1.5778 kilograms. So the idea is that when you fill this in, you're going to keep track of cart 1 on one side and cart 2 on the other. And eventually, you'll start adding up everything, the initial momentum, the final momentum, the initial kinetic energy, and the final kinetic energy. And that is seriously all we need for inelastic collisions. So we're going to pause very briefly and set up for elastic. Okay, so you can see one cart in the frame. I'm going to move it so you can see both carts just about to collide. We'll autofocus and we'll zoom in a bit. I'm being very careful here. I just want you to see what happens during the collision. So we're going to run it, and then we're going to do the collision. And we noticed that we made a mistake, is we heard the collision. We shouldn't have heard it. So we're going to do it again. Perfect. So we were kind of ran out of time. So we're going to reset it. We're going to go and set up to take more time. Basically, it'll take 10 seconds of time instead of 5. Okay. So we'll reset, go again. Perfect. And we lost our data. This thing's being a pain in the butt. Sorry about that. We'll do it one more time. Okay. So now I'm going to close a bunch of stuff. And let's see if I can't. We've got enough power here, I think we'll get this. So we got two curves. The green curve represents the heavy cart, cart 2, that is at rest until this point. At that point, there's a collision, and then there's some motion along with that. I want to zoom out a little bit and autofocus. There we go. So right at that point, that's where the collision occurs. You notice that's a turnaround point, but that's not what we think, that we don't know exactly what's going on there. We just know that it changes direction. So we're going to do a curve fit, and we'll analyze curve fit position in red. We'll do a linear fit. So this is the moving cart. That is cart 1. For cart 1, its initial velocity is 0.33456 meters per second. Okay. So we'll go back and we'll curve fit again for the stationary cart. But then we just realized, hey, that's 0. So V2 initial is 0. Okay. So we'll cancel out of that. Now we're going to select some area. All right, so we're going to select some area past the collision, and we're going to analyze curve fit position in red. I'm going to do a linear fit. Now, what we get is we have 0.11805. That means the cart's moving backwards. That's why it's negative. So V1 final is minus 0.11805 meters per second. Now we're going to do the same curve fit for cart 2. But before I do that, I want you to note that we have a uniform direction that is positive. So regardless of what the sensor tells us, when we realized that cart 2 went in this direction, it had a positive velocity. All right. Now, it will tell us that it has a negative one, because it's going to assume that if you get close to the sensor, you have a negative velocity. But that's not what it's going to be. So we'll do the curve fit one more time. And here we have 0.11055, and that's positive, plus 0.11055. And so we're going to go in and we can put in our times, our masses. So 0.5109 and 1.5778. Now, as you calculate through these, please take all of the sig figs you can until the very, very end. So there is the numbers that I have that you should have. And again, the signs are important. All right, is when we measured V2, we measured on the sensor a negative number, but it was going in the positive direction. So we take it to positive. And V1, we measured a negative number and it was going in the negative direction. All right, so we'll pause one more time. Again, let me hold this up here and then we'll pause. I can get this to hold. Okay, so we have cart 2 sitting here. I promised I would show you what happens when equal masses collide. So cart 1 is going to come in and bounce off cart 2. This is, I think, impressive. Cart 1 stops, and all the momentum goes into cart 2. We'll talk about this some more. Obviously, I'm pre-recording all of these labs, but hopefully we'll talk about what happens if one of these carts has a massive amount of mass. Like, what if I just hold this down and do the collision? Then, basically, it reflects the moving cart. But if I don't hold it down, and I allow the cart to come in, it transfers all the momentum. All right, so that's your lab. I hope you enjoy this. I don't know if you enjoy it. I mean, it is lab, but you will probably like seeing. You'd probably want to be in person for the next lab, but I don't have that choice. So you're going to see me get sick. It's been a around a lot. I know it should be